Hello, this is Mark Lensing. I'd like to introduce you to our HVAC line of motors. We'll talk about the motor, give you an overview of our motor market and HVAC product portfolio. We'll talk about some things unique to these HVAC motors, and they're typically used along with drives, and they present some specific challenges. We'll talk about that in some detail, and also what makes a HVAC motor different from others. The North American total available market's around $6 million US. It includes cooling towers, evaporators, fan wall, blowers, heater units, and industrial fans. Our product is laid out and designed with several different categories, starting with our cooling tower motors designed specifically for high humidity type applications, and shaft grounding motors that are designed for variable speed. We have general purpose motors for HVAC, and our direct drive motors also have some very specific unique mounting capabilities. So our vertical chiller motor and cooling tower motors are specifically designed to thrive in high humidity environments. Each of the joints around the motor housing and end plates, the terminal conduit box, all have silicone sealing around all the mating surfaces. Special varnish process is provided to protect the windings from moisture and resistance to VFD-induced type failures. Multiple lifting provisions are provided, and the oversized rotatable conduit box adds flexibility to the mounting and installation process. These motors can be mounted in a number of different configurations: vertical shaft up, vertical shaft down, horizontal. Motor is equipped with seals to keep moisture and dust out of and drains to provide relief from condensation no matter which way the motor is oriented. Ingress at the shaft is prevented by 3 layers of protection. There's a slinger to start with, and in front of the slinger is a V-ring seal and then a lip seal. All this prevents any kind of moisture or dirt ingress into the bearing cavity. The conduit box is protected and the motor lead opening is protected by neoprene gasketing, including individually sealing around each motor lead coming into the conduit box from the motor. Easily removable drain plugs are located at the conduit box and the motor face to allow for proper drainage in any mounting orientation. We have double dipped and baked varnished windings to further protect the motor windings from any kind of moisture. Also helps with inverter type failures to prevent those from happening, and Class F insulation. General purpose HVAC motors are designed with a rugged construction in open or TEFC and rolled steel or cast iron. External shaft grounding provisions are provided. We also provide a bar coating for easy identification and replacement of the motor. Condenser fans have specific mounting capabilities, very unique to each of these fan applications. Have a rugged construction. Again, are drop-in replacements for most of these fan applications. Let's talk about our variable speed motors. The variable speeds, as I indicated, have some very specific concerns, typically around the shaft grounding and shaft currents. Common things about this motor is that we have a lipped conduit box to protect from ingress around the conduit box openings, and Class 8 insulation to provide a higher temperature differential. Typically, these motors run at a Class F temperature. Class H insulation gives them further headroom for higher temperatures that could be associated with inverter use. Let's talk more about the shaft grounding and shaft currents. As demonstrated by this drawing, the yellow line indicates how the shaft has a voltage induced on it. The voltage creates a current in the shaft that typically exits through the path of least resistance, which typically are the bearings. When common mode voltage is present, you need a means to isolate the bearings or divert the current away from the bearings by providing an easier path. In motors less than 100 horsepower, the typical solution is to install a shaft ground, normally placed internal at the drive end of the motor. Internal installation protects the brush ground from losing its contact with the shaft due to contaminants. In motors larger than 100 horsepower, up to NEMA 449, a shaft ground should be installed internal to the drive end of the internal to the drive end of the motor, and the opposite drive end bearing should have an isolated insulated bearing installed. Common causes of these shaft currents are long cable lengths between the motor and the drive, maybe not proper shielding at the motor cable from the drive. Sometimes damaged motor cables could cause this. Poor motor grounding is definitely a culprit, and sometimes drive tuning will affect how shaft currents are created. So what does a shaft current or the voltage look like? We actually captured that on a piece of equipment showing the voltage rise and then the sharp decline as the voltage discharges through the bearing back to ground. It's this discharge that is particularly damaging to the bearing, typically causing pitting in the bearing and also around the races. This more clearly demonstrates or shows that rise in voltage. The chart to the left shows the voltage rise without any kind of shaft grounding applied to the motor. And the chart to the right shows what that same motor looks like, motor shaft voltage looks like with the shaft grounded. Notice that the shaft voltage stays at 0 with the shaft grounded. This spike was generated by an inverter to test the effectiveness of the shaft ground. You can see that the trace to the right prevented the shaft from charging and building that damaging current. This is what that discharge looks like on the bearing races. These damage is called fluting. It adds friction to the bearing as it rotates, and that friction causes excessive heat and eventually leads to the failure of the bearing. Here's some common devices that are used to mitigate shaft currents. We have a Baldor shaft grounding brush up the upper left-hand corner, starting to the left, going to the right. Ceramic ball bearings, which is a much more pricey fix for shaft currents. It also isolates and eliminates the current from passing through the bearing. Aegis has several shaft grounding brush rings that are also used to mitigate brush currents, and the current diverted rings by ImproSeal. And we have a shaft grounding system that's also a little bit more of a pricey option. It has a brush that rides on the end of the shaft through this mounting arrangement. This concludes our presentation. You can get the full presentation version of this and more in our Baldor Reliance Motor Academy. You can enroll in this training anytime using code K507 on the ABB My Learning portal. Thank you for your time, and thanks for listening. Have a great day.